Hi everyone. One of your classmates had a question about using reference angles to find the exact value of a given expression. And since this is an important concept, I did just want to make another video to supplement Professor Messenger's video about this. So I'm going to walk through a few steps. Definitely rewind this if you need to, because I'm not going to have as much typed out as I have in some of my other videos. I'm pretty much going to walk through it. So the first thing that you need to do is to figure out the quadrant that your given angle theta is in. So right now we have sine of 7 pi over 6, which means then we need to figure out where 7 pi over 6 is. Well, 7 pi over 6 is definitely greater than pi, so that means we're going to be down here in the third quadrant. The reason why that's important is because we need to determine if sine is positive or negative in that quadrant. So remember, when we're looking at our signs of our trig functions, our first quadrant, everything is positive, so we have our A. In our second quadrant, sine is positive, only sine is positive, and its reciprocal trig function. In our third quadrant, only tan and cotan are positive, and in our fourth quadrant, only cosine and secant are positive. So sometimes we can remember that by thinking ASTC, or all students take calculus. Just make sure that you're moving around in a counterclockwise direction with your quadrants. And then, like I said, they're reciprocal trig functions. So where sine is positive, that means that cosecant is also positive. Where tan is positive, that also means that cotan is positive. Where cosine is positive, that also means that's where secant is positive. So for our problem, we have sine of 7 pi over 6. We found that 7 pi over 6 is in the third quadrant, which means that we're looking right here to determine if sine is positive or negative. Well, in the third quadrant, the only thing that we have that's positive is tan. So that means that the sine of 7 pi over 6 is going to be a negative answer. Okay, so our answer is going to be negative. With that in mind, the next step is to then find your reference angle. All right, so our reference angle still goes back to this idea of the quadrant that we're in, because in order to find our reference angle, which is going back a section or two, we need to figure out how that relates to 7 pi over 6. So remember, for our radian measure, is that in your first quadrant, that's where all of our reference angles lie, so that's theta. In our second quadrant, we would figure it out by doing pi minus theta. In our third quadrant, we would do theta minus pi. And then in our fourth quadrant, we would do 2 pi minus theta. So again, we're in the third quadrant for 7 pi over 6. So in order to figure out what the reference angle is, which we usually denote by alpha, we need to do theta minus pi because we're in the third quadrant. So that means that we are going to have alpha, or our reference angle, is equal to 7 pi over 6 minus pi. So pi is the same thing as saying 6 pi over 6, so that way we can subtract. So we really end up with pi over 6. Now, Professor Messenger in his video also commented that when finding reference angles, especially in radian mode, is that we really can just look at the pi over 6 and essentially ignore the coefficient. That is definitely okay, so that way you don't have to do all of this work. But if you have a degree measure, then you're going to have to do this. Just remember that where I have pi, that really represents 180. So in your second quadrant, you'd have 180 minus theta. In your third quadrant, you would have theta minus 180. And then in your fourth quadrant, you'd have 360 minus theta. Okay, so piecing together what we have so far is we have the fact that sine of 7 pi over 6 is going to be equal to negative, right? We got a negative answer because we're in the third quadrant. That's what we found in number 2. Sine of our reference angle, which is pi over 6. So we need to rewrite this using our reference angle and understand that we're going to get a similar answer, just whether or not it's going to be positive or negative depends on the quadrant that we're in. So 7 pi over 6 was in the third quadrant, which tells us that sine is negative, and it also helps us to find the reference angle, which is pi over 6. Because now that we have this, now we're going back to our special right triangles in order to figure out what the exact value is. So remember, your special right triangles is that for pi over 6 is really 30 degrees So if we have 30 degrees down here, and I'll put 60 up here. Our sides then are opposite your 30 is 1, opposite your 60 is square root of 3, and then opposite your right angle is 2. So this is definitely something that you have to know and memorize for your test in order to make sure that you get the right answers to all of these problems. So understanding first, I have this triangle in degrees because that's how it's originally shown to you, but you do need to know that 30 is pi over 6 and that 60 degrees is pi over 3. So for our problem, we're really trying to figure out what sine of pi over 6 is, or sine of 30 degrees. Well, remember, sine is opposite over hypotenuse. So in this case, we're going to have negative, your opposite side is the 1, over your hypotenuse, which is always the side opposite your right angle, is the 2. So that means that your answer here is negative 1 over 2, or negative 1/2. So sine of 7 pi over 6 is equal to negative 1/2. All right, so let's try another one if we want to find the exact value using reference angles. Here we have cosecant of 5 pi over 4. So first, again, we want to figure out what quadrant it falls in. So 5 pi over 4, again, is definitely more than 180 degrees, or more than pi, so we are actually going to be back down in our third quadrant again. So with that in mind, then our second step is to figure out if cosecant is positive or negative in the third quadrant. Well, part of what you need to remember for this problem is that cosecant of theta is equal to 1 over sine of theta. All right, it's the reciprocal trig function for sine. So when we're looking at our all students take calculus, looking at all 4 of our quadrants, we're really looking at our third quadrant here, which is tan. So tan is positive, and its reciprocal trig function, which is cotan, which means that cosecant and sine are both negative. All right, so we are going to be negative again. Our next step then is to figure out what the reference angle is. So in this case, we have 5 pi over 4, which again is in the third quadrant. So we did say in the last slide that if we have 5 pi over 4, that your reference angle alpha is really just pi over 4. But if you did go through the math behind it, you would have 5 pi over 4 minus pi, which would end up being 4 pi over 4 for pi. So you have 5 pi over 4 minus 4 pi over 4, which does still get you the pi over 4 that we need. So then finally, we want to understand how to get our answer. So cosecant of 5 pi over 4 is going to be the same thing as doing negative cosecant of pi over 4. So we got the negative from the fact that it's in the third quadrant, and then we got the pi over 4 as the reference angle. So that's going to be the equivalent answer. So again, we need to go back to our special right triangles. Pi over 4 is 45 degrees, so that's going to be our other special right triangle. So both of your angles here are 45, and both of your sides are 1 and 1, where your hypotenuse then is the square root of 2. So again, cosecant is the reciprocal trig function of sine. So a few ways that you can do this. I'm going to rewrite this as negative 1 over sine of pi over 4. That's one way to do it. Or if we know that sine is opposite over hypotenuse, that means that cosecant is hypotenuse over opposite. But if we keep it this way, you're going to have negative 1 over, so your sine of pi over 4 again, so sine, remember, is opposite over hypotenuse, so your opposite side is 1 over your hypotenuse, which is going to be square root of 2. So we have negative 1 over the square root of 2, which means this actually becomes negative 1 times the square root of 2 over 1. When we're dividing fractions, we flip the second fraction over to actually give us a final answer of negative square root of 2. So cosecant of 5 pi over 4 is the same thing as negative cosecant of pi over 4, which is negative square root of 2. So for this last problem, we have sine of negative 210 degrees. So now we are in degrees, not radians, but the process is still the same. We also have a negative angle, which is going to impact how we find our reference angle. So first, again, we still want to figure out what quadrant we're in. So negative 210. Remember, in the negative direction, that means I am going clockwise. So negative 210 is going to be greater than going around negative 180 degrees, which means we're going to be somewhere in our second quadrant. So it's going to be going this way. So our second quadrant here. Then next we need to figure out in our second quadrant is sign positive or negative. So we have all students take calculus again. So we're in our second quadrant. So in this case here, sign is positive, which is a good thing. So that means that our answer is going to be positive as well for the sign of negative 210. The third step is that we need to figure out what our reference angle is. Now here, my suggestion is to figure out what the coterminal angle is. There's already so much stuff that you have to remember that I think it's probably easier for you to get this to be a positive number, a coterminal angle, versus trying to remember your reference angle locations and formulas for negatives. So my suggestion is to figure out your coterminal angle, which means in this case we would be doing negative 210 plus 360, which is going to end up giving us positive 150. So 150 degrees is coterminal, which means that if I'm coming around this way in the positive direction, we're going to end up with the same side for the end of our angle. So then from here, we are now thinking of this as doing the sine of 150. That's your coterminal angle, so sine of 150 degrees. That's going to be the same answer as sine of negative 210. So then now we would want to find your reference angle for 150 degrees. So in the second quadrant, remember for your degrees, we're going to have theta in your first quadrant. In your second quadrant, we're going to end up with 180 minus theta. In your third quadrant, you're going to have theta minus 180, and then in your fourth quadrant, you're going to have 360 minus theta. And again, these are exactly the same as what we had for our radian measure, because pi is 180 degrees. So don't try to think of it as two completely different situations, that the process is still the same, how we find them is still the same, it's just that rather than having pi, we have 180, because they're equivalent to each other. Okay, so in finding our reference angle then, 150 or negative 210 is in the second quadrant, so that means we're going to be using this formula in order to find it. So our reference angle alpha is equal to 180 minus 150, which would be 30 degrees. So that means that we are then trying to find sine of negative 210, which is then equal to a positive sine, we found that at number 2, of our reference angle, which was 30 degrees. So sine of negative 210 is going to be the same answer as finding sine of 30 degrees. So again, going back to our special right triangle, which we did back in the first problem, we have our 30 degrees, our 60 degrees. So opposite your 30 is 1, opposite your 60 is square root of 3, and then your hypotenuse is 2. So again, sine is opposite over hypotenuse, so your opposite side is 1, your hypotenuse is 2. So that means that our answer here is positive 1/2. So the sine of negative 210 is the same thing as sine of 30, which would be equal to 1/2. So pretty much these are the steps that you're going to want to follow anytime you're trying to find the exact value using reference angles. And this is a very important concept, so you do want to make sure that you understand it. It's pulling in everything that you've done so far in sections 5.1 and 5.2.